Okay. 4.7 Law of Sines. Law of sines and cosines are used to solve oblique triangles, triangles that have no right angles. So to use the law of sines, you have to be given triangles with angle, angle, side. That's two angles with a side on the outside. Or angle, side, angle, which is two angles with a side in the middle. Or side, side, angle, which is two sides and an angle on the outside. To use the law of cosines, you need to be given side, 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 which is three sides. Or side, angle, side, which is two sides and an angle in between. Okay, so the law of sines, this is what they give you in your book. Just as an FYI, I usually write it the other way, so I'm just going to write it down. I usually just do the side over sine of A equals B over sine of B. I don't care which way you do it. I probably will just do it the side length on top and the angles on bottom. Just because in every other textbook, that's the way we've always done it. This particular book does it the other way, but it's the same thing. And all your lowercase letters are sides and all your uppercase letters are angles. Okay, so number one, if we have angle, angle, side, solve if possible. I'm going to draw my triangle. And obviously when I draw them, I'm not drawing them to scale. So my C is 102.3. I'm just doing it for placement. My angle B is 28.7. And my little b, which is the side across from angle B, is 27.4. So when I set it up in law of sines, I don't have A. I don't have angle A. I have little b, but I don't have, oops, and I do have angle B. I don't have little c, but I have angle C. So the things that I need to find angle A, I need to find little a and little c. And if you'll notice, you already have two angles, so all you have to do is do 180 minus 28.7 minus 102.3, and you'll get your angle A, which comes out to be 49 degrees. So this is 49 degrees. Next, I'm going to find the two sides. So my A over my sine 49 equals 27.4 over sine of 28.7. So my A, cross multiply and divide. So that's 27.4 times my sine of 49 over sine of 28.7. That is going to give you a little a of 43.06. Then if I want to find little c, you always want to go back and use the original fraction, not the one that you've already rounded. So 27.4 over sine of 28.7 equals little c over sine of 102.3. That means I'm going to cross multiply and divide. So my c is going to be equal to the 27.4 times the sine of 102.3 divided by your sine of 28.7. Because keep in mind, when you solve proportions, you cross multiply and divide. So that's going to give me a c of 55.75. Okay, the ambiguous case, this is the graph that they give you in the book. I'm not going to teach it to you this way because more than likely you are not going to remember the A's and the B's and the H's and all that kind of thing. So I'm going to show you another way to do it, and as well as I give you a demonstration class. So if you have side-side angle, that's the ambiguous case, you have the possibility of having 0, 1, or 2 triangles. Okay, so if you have side-side angles and have the possibility of having 2 triangles. So if this is what the picture looks like in the book, okay? I find it easier just to give you the demonstration and kind of have you understand where it's coming from when we do the math. So right now, if I've got 2 sides and a fixed angle, so the 2 sides are fixed. If this side here across from the angle is shorter than this one, then you're either going to have no triangles or two triangles. And I'll show you how. Because sometimes it might extend all the way down and give you two triangles. So on this particular one, we'll have to do some math to see if it's going to make a triangle. Oops. So if you look at this one, this is where you would look like you would still have a side across from it that's smaller than this one, but it's a little bit longer than the one on the previous screen, and this would give you two triangles. So the one on the previous screen would give you no triangles. This would give you two. And we did a demonstration in class. And it's also on your notes. If the side across is greater, like this one over here is greater than this one, then you're going to have only one triangle. There's one way. There's no way for you to take this 7 and swing it over here to get it to fit. It will fit on the other ones, but it won't fit on that one. Okay, so let's try some. And I'm going to show you mathematically how to figure out if they work well. So when I'm setting up my triangles, A, B, C, A is 22, B is 12, A is 42 degrees. So right now, this side that's across from your angle is bigger than this side. So there's only one triangle. So anytime this one across from here is larger than the other given side, this one here, then you have one triangle. So I'm just going to set it up. 22 over my sine of A equals my 12 over my sine of B equals my C over my sine of C. Now you'll notice that you don't have anything in C, so you're going to have to solve for this next. So when I do 12 times sine of 42 over 22, that equals sine of B. So keep in mind, and I'll show you why this is only going to be one triangle and not two. So when you stick 12 sine 42 in the calculator, you're going to get 0.3650. Now mathematically, if you remember from earlier, you should have sine be positive in two quadrants. So if I do second sine, you're going to get an angle of 21.41 degrees as a reference. When you do second sine, second cosine, second tangent, it always gets you a reference angle. So you have the possibility, so triangle 1, triangle 2, and I'll show you why there's only one triangle. So we already know we're going to leave the A at 42. Now you know your B is going to be 21.41 if it's in the first quadrant. But this angle here technically is 180 minus 21.41, which would get you a possibility of having 158.59. However, you'll quickly notice that you did that because mathematically sine, if I gave you this is the only problem like I would on a test, and I said solve for it, you can type in sine of 21.41 and sine of 158.59 and get 0.3650. You're not going to get anything higher than those, but you'll notice that when I go to find my third angle that's missing, this is already over 180 degrees. So basically that's kind of an extraneous solution. So the purple one this was angle B. So then that's going to make angle C, if you add them, subtract them from 180, 116.59. And then, oops, I guess I'll leave that here. Okay. Let's not do that. So then if I set up my law of sines, this is 116.59. Use the original in this one. My C is going to equal 22 times sine of 116.9 divided by my sine of 42. I got that by cross multiplying. Pretend that you don't have this one here in the middle. 22 times sine of 116.59. Oops. 59, not 9. Sorry. 22 times sine of 116.59 divided by sine of 42. And you'll get that your little c equals 29.40. Sorry I crammed this all in one screen. Next one, I have A, B, C. A is 15, B is 25, A is 85 degrees. And again, this side across from here now is smaller than this other given side, than this one here. So that means I have 0 or 2 triangles. And I'll show you how to have the calculator tell you which one it is. So let's set it up. So my A divided by my sine of A equals my B over my sine of B equals my C over my sine of C. So then I've got sine of B equals cross multiply and divide. That's going to give me sine of B equals 1.6603. And if you did second sine of 1.6603 in your calculator, you're going to get error. And the reason for that is, if you remember about your sine graph looks like this: 0, 1, 0, negative 1, 0. The highest it will go, the lowest it will go is negative 1. So this is never going to be bigger than 1. So what clues you in when you have 0 or 2 triangles that you have no triangle is that your sine of B is bigger than 1, 1.6603. So that means these measurements do not make a triangle. So if it's positive, if it's over 1, you have no triangle. So that means if I know that it's a 0 or 2 possibility, because this is smaller than this one, and this is smaller, then I'm going to get 2 triangles.